Good evening to everyone gathered. Welcome to this 21-day faculty development program on data science tools. This is day 3, and today's session we will be joined by Vignesh Kumar Venugopal sir. Today's session will be on. Excuse me. Sorry. He is a cloud-based cloud database platforms engineer with 10 plus years of experience in PostgreSQL and MongoDB with Python and automation labs. He is currently employed with Intel, and his areas of interest include 3D design and visualization, artist and animation rigging. He has knowledge on rotoscoping, camera rigging, match moving, and photogrammetry. It is an honor to have you conduct this session today, sir. Thank you.
Hey, thank you. That was a overwhelming welcome, right? So thanks for the great words, and it's been pleasure for me to also to join here with you guys in this evening to walk through the data platforms and what would be the future that data platforms will be having, right? So, just this would not be a formal session for sure. Do not expect me to share some PPT or just walk through because I'm kind of a person who always want to give you should definitely have a good takeaway at the end of the meeting, right? So I'll put it in a way that you can picturize it in your mind, so you can stop me whenever you have any doubts. Okay, this is not going to be a formal session at all. Okay, shall we start?
Sir, are you able to present now?
No, I'm not going to present anything because if I present, everything will be like technical jargons. No one will be able to understand anything. Trust me. So it's going to be purely a vocal session and also interactive session. Definitely, you will have some key takeaways when you end this meeting, right? So definitely, you'll have a idea like what is data, what is database, what is infrastructure, where you should head your future into, or your co co-future, right? So that we call it as a co-future because the future everything relies on AI, ML and stuff. So it's very hardly I can hardly put it up into PPT and present it because it would be completely new for you guys. There is no point in presenting, so I'm a very practical guy. So I'll put it up in a way that you will understand and you can easily get it into your brain so that you can take something as a takeaway from this meeting, right? With that being start, all right, thanks for the welcome guys, and I'm pleasure to be part of your session today. And I wanted to understand one thing, right? So even anyone can collect the information from the team and let me know, or you can put it up in a chat, or anyone can voice it out, right? So what do you know about like database and data science, right? This is very, very important question before I proceed to the topic, because without understanding the basic, I'm not going to proceed further. Mm. Okay. Okay, let's give a couple of more minutes for people to type in. Database is a place where we can store data sets, collection of interrelated data. Okay, nice. I just remember my college days. Okay. So the moment when I start relieving the truth, right? So you will be amazed because what all we thought, whatever was taught to us in our college or school, nothing is related to database or data. It's completely different than what we think, right? So that's the reason I just wanted to hear from you guys before I say something. Okay, with that, we have received so much of responses. Thank you. Thanks a lot for being interactive. And okay, it's time to break the fact. So database is nothing but it is a simple engine which is required to process a huge data set. It's not like collection of tables. It's not like collection of records. Nothing. Collection of your data, records, or tables are called as data sets. They are not a database. Database is nothing but it's an engine which will help you to store your data and pull out your data and query it in a more what do you say, faster way, right? That is what database and database engines do. So I had this thought in my mind before I was starting my career with this database administrator. I was a database administrator. Then I thought, okay, I've been doing all monotonous work all these years, like take a backup, restore, understand what kind of data is going in, no, put a full stop. Let's jump on to something interesting. Then I started deep diving into the actual product itself. So when I call a product, there are multiple databases in the market. I mean, database engines in the market. Some call it as SQL Server from Microsoft. Some call as Oracle SQL, right? So, and some call as open source MySQL and Postgres. So let me break the myth behind the companies why they have the strategies. Okay, so first thing is like when people go for Microsoft SQL or Oracle, it generally states for any company that data is crucial. They do not want it to take risk, and they wanted someone else to manage their data. That is what it means, because the licensing cost of SQL and Oracle are very high, very huge, right? I'll tell you why it won't work for the future technologies and future companies. I'm not audible.
No, sir, you are audible.
Okay, cool. So I'll not tell you why it won't suit for the future technology. Say, future is all about apps, right? Could be mobile app, it could be web app, it could be desktop app, whatever, XYZ. For any kind of app, there should be or there must be a reliable backend required, right? So when you go for a licensed set of database engines, what really is going to happen is company will not be comfortable enough to spend whole of their profit into licenses and renewals. So they choose something called as open source. Okay, take the source which is already there, open in the market, modify it accordingly, hire some engineers, modify it accordingly, use it for yourself or sell it for others, right? This is what is called as open source database scaling, or open source database engineering. Okay, there is a difference between administration and engineering. So administration is nothing but you have the infrastructure, you have the database setup, you just maintain as it is. There is no kind of a feature that you're going to add it, or no kind of specialization that you're going to add to your product. When it comes to engineering, you're going to analyze, you're going to think about how can my product hold a better data set than any other thing in the market, right? Say open sources, let me take an example, Postgres and MySQL, MariaDB, right? These are open source databases. Collectively, these are highly potential databases that can save an RDBMS data. You guys know what is RDBMS? Which is a relational database management system, right? So table data, columnar data. I mean, this is quite common fact. So let's come back to the reality and think, you or myself, or like thinking about starting up a business, or like starting up a own company, which one do you prefer? Would you prefer to hold the legacy SQL system and end up paying licenses, or choose the best one out of market in the open source, hire some good engineers and give a good product? Definitely we'll go with the cost efficient way, right? So that's what company is also doing. And why I'm saying all these things is because it is going to matter the most, because Postgres is open source. The beauty about Postgres or any open source is you take the source, you engineer it, you keep it for yourself, or you sell it to others in a different name. Call it as XYZ, ABC, whatever you need, right? So you can make a commercial income out of it. That is why, that is where the DevOps thing started emerging in the market. Before even knowing what is DevOps, I mean, the general mentality of people nowadays, right? So anything which is trending, Python, okay, I will go learn Python. So why do you want to learn it? How it is going to benefit me by learning that, right? So think in this perspective. Same way, when you come to database engineering or database administration or say data analysis, basically you call it as like a data analysts, right? Or like a data design engineer. So there is a difference between data engineer and data design engineer. People generally call it as like a data analysts, right? So which is also a good role, but without knowing the concepts of how your engine is going to store the data, you won't be able to predict or write a query that can pull out the data faster. Agree with me? Without knowing the basics, you cannot jump into the pool and dive. Sorry, I would not be able to turn my camera because I'm not supposed to. That's why. Mm. So coming to the topic, right? So it is very, very clear and very, very hard statement for you guys to understand. If you wanted to learn data analysis, you might have a question, why should I learn database engineering or database administration? When you don't know how your data is going to enter in or how your data is going to process within the database engine, as a data analyst, your work is to analyze the query and see why the query is taking so long, why the query is taking, what is the wrong, what is something wrong with the query, or how can I optimize the query. Without knowing the basics or without knowing the design architecture of your database engine, for anybody matters, they won't be able to shine up well in the data analytics part, right? So there are some courses in LinkedIn and all, like you go just 30 days, learn what is select star from, learn what is insert star from, learn what is update, delete, curt statements, right? So no, straightforward, no, it cannot work like that. Because take for example, you're working on MySQL or MariaDB, it has its own way of processing the data. The engine is efficient enough to process only a designed amount of data or architecture. If you use Postgres has its own way of dealing and processing the data and data sets, right? So different pieces of data engines has different set of pros and cons. So before jumping into something, we need to understand why that is required or why I need to know that, right? So now let's come into the picture of Postgres, which is like, I will definitely share you a PPT, maybe in a mail or something, because I won't be able to share it right now. So sorry for the inconvenience. So whatever I said, it will be there in the PPT. Don't worry, you can recollect it. So basically, I also wanted to understand any faculties who are pushing their students towards the future trend, which is like AI, ML, or data analytics. Anyone? Because I have some questions for them, that's why. Okay, seems like no one wants to answer. That's fine. So let me explain it. All right. So whoever are interested in the data engineering, just put a thumbs up. Whoever is interested with data analytics, put a thumbs down. Right. So it's actually good to see, like a lot of thumbs up and thumbs down coming, because people know the actual difference between both of them. Wherein in my previous sessions with other thing, I was not able to get such kind of responses, and that's because lack of these basic knowledge, right? So good. This is the reason I was explaining all these while, to make you understand the difference between them, right? So now let's actually jump into the data part. Say your data is not very minimal now. It is very huge. It is in data lake. It is in data factory. What all it means is your data is so stored somewhere in the cloud in an non-reliable fashion, or like a non-representative model. What it means is it is kind of like a dumped data which is not meaningful, unless and until you take the data, do a mining, do a model out of it, and use it for your organization. And that is what is the work of a data mining guy. And the data mining guy will send out the result to the data analyst to give a better structured result or a modeled data query, right? So this is what is all about. So why Postgres comes into picture here? I will tell you why, because before me telling that, I wanted to know how many of them from this group knows Postgres other than Microsoft SQL or Oracle. Be transparent upfront, right? So, okay, most of them don't. Cool. Postgres, okay. I should also mention this. So be proud, guys. We all learned C program, okay, and your Postgres is built on C completely. Not only Postgres, most of the database engines which you're dealing in day out are built with C program. So if you are like good enough in C program, or you can call yourself as an expert, pat on your back, right? So you have a great future. Is it not audible, guys?
You're audible, sir.
Okay. Okay, cool. So now let's jump into the actual picture of why we had scheduled this meeting, right? So Postgres. So okay, is it any better now? Okay, why Postgres is because Postgres is open source. Is that the only reason? No. People think about the capability of any product, right? So when it comes to open source, even when I'm not paying, I wanted some kind of what do you say, the features to be available, right? Since it's open source, I cannot accept a blind product. So Postgres is really a competent database to Oracle product in the market. The reason is because it has a high efficiency to store the data and also compute the data. uh, there are two flavors of Postgres. Okay, one flavor is the vanilla flavor of Postgres, where you manage like one instance of it and do the normal operation. Postgres, Postgres. Maybe the translation is happening in a wrong way, right? So don't worry, I'll be sending the document or like PPT to you, so you won't miss out the things. So let's come to the topic back, right? So when actually the product is compatible enough in the market, I still wanted to do some engineering. So what I do, I take Postgres. A company called Greenplum took Postgres. They engineered it completely end to end, and they made it equal to the big data, which means it runs multiple instances of Postgres just to process a single chunk of data, which means it is a big data architecture. Meaning a small chunk of data, when it is processed by multiple resources within a VM or within a server or within a infrastructure. So please show us visually. Sure, I would love to, but currently due to my restrictions with the office assets, right? So I won't be able to share anything now. Definitely, maybe in next session or something, I would show you, right? So sorry about that. Yeah. So coming back to the topic, so one Greenplum server is equal to 15 Postgres database servers, which means even Greenplum is free of cost. It's open source, which means you have two flavors of database engines which can hold the normal type of data, and another engine or other built-in product of engine which can hold the big data part of your data sets, right? So now okay, not able to follow this session. Sure, I will send you the PPT. So with this regard, what happened is Postgres had announced a big time announcement in the market telling, hey, I'm going to completely change the big data market. And they tied up with Greenplum, company called Greenplum, and they released something called as Greenplum, which means it is a data warehousing database engine. It is more powerful than anything what you have it in the market, even if you pay, right? Which is offered for free of cost. And Have you guys anywhere thought about like why people are giving it for free? Because they need data, right? They need the performance data, they need the analytics data, what has been, how the product is performing, right? That is why they give you things for free. And when it comes to Postgres, I would quote definitely MariaDB does that. And when it comes to Postgres, the source code itself is available in the GitHub, which means you have access to the complete source code. If you know the flow and structure, and if you know to code better on C program, I would say you would end up your career with Postgres data engine and what data architect, somewhere in that role, right? So I'll tell you why people have a mindset like data analyst is a white collar job and database administration or engineering is a red collar job, right? So nothing like that. The myth is simple. So data engineering, only when there is a data issue you work. So you know only the data part, data flow part of your application. You won't be knowing the entire infrastructure or what kind of business is involved with setting up these infrastructures, right? So when you wanted to know about like what kind of business infrastructures required for setting up this environment, run your application smooth, and also design a high-end architecture for your application backend, right? That is where you need to choose database engineer or database administrator. These are the two career paths which you need to choose if you are interested in one among of them. Okay, data analyst is purely for someone who deals only with data, right? And that's the reason I was stressing all these while, like without knowing, understanding how the engine works, you can't even predict like how your query will be performed within the database engine. Say if you're running some kind of a query chunk in your Postgres engine, you don't know how it performs, so you need to run multiple times, do a explain on that, and check like what kind of query route that is giving, what kind of performance analysis it is suggesting you to do. But all these things will not be offered to you directly when you go to data analyst. Your job is to fix the data, and when there is a data flow issue, you will be jumping into it to resolve it. It could be like a query switching slower, it could be like a bigger data chunks not modeled properly. Anything of this sort will be in your head, right? That's what it means. Okay, so coming to the Postgres, right? So how many of them are aware about the Kubernetes containers or Docker over here? Just thumbs up or thumbs down. Nope. Okay, almost everyone. No. Cool. So before this, the database provisioning or the database, whatever you are trying to install was as a monolithic service, which means you create a VM, you deploy Postgres or MySQL or Maria, any kind of instance, install some instance over there. That is the thing, right? Nowadays, everything is container based and microservices based, which means anytime you want, you can spin up a new container with least amount of time and with least amount of energy or resources. That is what it all means. Yeah, surely I'll show them on visual sometime when I get a chance to present my screen, right? So I'm not supposed to do it in my office assets. That's the only problem. So coming to this thing, so let's focus something. I wanted everyone to put your ears here, right? So this is going to be very, very important. So anyone who wants to learn scripting, or anyone who wants to grow their career in automation, or like current trend of DevOps. DevOps is, as you know, like it's a integral collaboration of all the tools which are integrated to provide some solution, right? That's called DevOps. So earlier it was a monolithic service. There is some manpower required to install things manually, set up things manually, deliver it to your customer or consumer. Now it is all scripted, automated. Everything is managed within the configuration files, which means it's a push and pull based deployment services, right? When I call it as a deployment, say you run a company, like you want to have like 15 instances of Postgres, where another runs a company who has like 100,000 instances of Postgres. For 15, it's considerably okay to spend some manpower to install it manually and deliver it to their customers. Imagine like 1,000 plus or 10,000. The team grows, the effort grows, the energy grows. So in order to break all those things, what we do is basically create a container, or in simpler terms, container as are the lowest abstract of any working entity. Say if I wanted to develop an application has application server, database server, web servers. Agreed. So all these things will be stacked up into a single container. So when I spin that container, I have a prototype of that container, which means with that same settings, I can spin like how much ever time I wanted. That is the basic intent. Now, Kubernetes is one such tool which helps you to orchestrate your containers, right? Orchestration is nothing but automation with a balanced way. Say you're creating a container, you have Postgres or MariaDB or anything running on it, you need to have a high availability mechanism, right? High availability is nothing but there is no downtime basically, or there is a least downtime. That's what high availability means. So database or database mode, or like in the database world, you call something like replication. Whatever is there, your application is writing the data, it will go to the master, the write only node. Okay, and master will send all the datas which are written to its node, and it will send it to the other nodes which are secondary nodes. That is called as replication, right? You can achieve this replication in multiple ways, and one such strong way is like streaming replication, like while your database is on, so you can keep transferring the log files and make the other node up as possible and keep them always intact with lower delay. So any disaster happens on the first node, the second node will pick up as master. Okay, so here, how this happens? What is the thing which is bringing up the other node as master? So that is because you have something called as load balancer. Its basic duty is to route all the connections and route all your write informations to the one particular IP, and that IP will be always be pointing to the primary server, not to the secondary server. Secondary servers are always meant for read. You want any query like select commands and get some data, you can do always a query in the secondary servers, which is a replica server. Master server is something which is responsible for writing the application data, basically. Okay, so in the Kubernetes world and in the container world, everything is made like a blueprint. So everything is converted into YAMLs. YAMLs are nothing but configuration files. It's one format of writing the configuration files where your system understands it, right? So when these YAML files are spinned, so you have a brand new high availability cluster spinned up in a minute, which means which means you have a whole cluster ready with ease of few minutes and with no energy spent at all, right? That's what is DevOps. That's what is called as orchestration, and Kubernetes does for you. So now in the present market trend, wherever you wanted to go get some job, or wherever you wanted to go apply for some good position, the basic requirement will be asked to you is whether do you know anything about containers, or what kind of container orchestration tools you know, and how better can you deal with your infrastructure and your container services, right? So this is the whole intent of coming up into the open source market. So when you go for any kind of SQL or Oracle or SQL doesn't have their source code let open in the market. So people doesn't know how to do engineering on that. If someone has to do engineering, that should be Microsoft or Oracle. That's why they charge you. So this is the biggest secret which I wanted to tell you, why people should choose open source, right? So many people, even me in the college, right? For me, accordingly, I was remembering only SQL and Oracle when it comes to database. No matter what, I'll go learn the course, whatever it is, how much ever the cost is. No, that's not going to help. And also, like, let me speak from your career perspective now. Say for example, you wanted to apply for some engineering job, you will always end up with a product based company or product development company or a producer company, right? So when you actually wanted to go from the say I don't want to do any kind of engineering, or I don't want to learn any kind of automation, but still I'll go and support whatever is there present within, that is called as administration, right? Database administration. So you will end up with landing in some of the service based or consumer based companies like TCS and stuff. So the motto is for you to choose which one, where you wanted to land yourself, or where your students want to land yourself, right? If you're a professor, I mean, it would be a great thing for you to suggest your team or students in a right way, right? That's why I have to quote this. And one final thing about Postgres is this. Okay, before if I tell this directly to you, you won't understand anything. Before that, I wanted to understand how many of you have worked on Linux-based environments, or anyone knows the shell commands? Thumbs up, thumbs down. Awesome. So we see a pretty good number of thumbs up over here. So great. A Linux-based environment are high suited for any kind of open source engineering. Okay. So there is a I don't know how much of you have heard about it. There is something called a scope engineer, Linux scope engineer, which means sorry, madam, I will not be able to share my screen. So, which means you will be directly dealing with the kernel itself. In all our college days, we know kernel is like four rectangles and two squares connected together, right? Just kidding, don't mind me. So, here in the actual world, it is all about like source codes, right? So, kernel codes, you will be learning the actual registry level languages. So, this is called as Linux scope engineering. So, the biggest advantage of being a Linux source engineer or like a scope engineer is to build their career anywhere. Any company you go, this role is always open for you, because without Linux, the open source world is nothing. And without Linux, none of these orchestration tools, Kubernetes, nothing will be like operating as smooth as possible, right? So now our competent Mr. Microsoft has came with some new kind of innovation and said, hey, you know what? I'm going to release something new in the market, and I'm going to call it as a Windows subsystem for Linux, which means you can install Linux or simulate the Linux environment as your OS subsystem within your Windows OS itself, which means you are running one OS which will have two different kind of operation. One operation will be through the main kernel, which is your Windows kernel. Another operation is through the subkernel, which is the subsystem for Linux, right? So whoever has known the word terminal would be able to correlate with this. Terminal is nothing but you are invoking the basic shell for any environment, right? That's what terminal means. So since you guys are super interested and more enthusiastic about the engineering part, so you should definitely take a glance of to install the Windows subsystem for Linux and practice some Linux based stuffs over there. It's free, right? It's not licensed or something. It's free, completely free. You can download it, practice it yourself. So yeah, why I was saying this is because when you wanted to be a database engineer, remember, right? So this is one word that I learned from my corporate career experience, right? So I cannot call myself only as a database administrator, or I cannot say that if I'm a database engineer, I'll only work on database certain things, right? So I have to know how Linux works. I have to know what is storage. I have to know how networking is binded, right? So when you call database, many people have this kind of a perception that, okay, I'm a database engineer, I'll work on only on database. Even I had the same kind of perception. I never got the opportunity till now to just stick with that, right? So always I end up working on storage, always I end up fixing the network devices or network binding protocols, or I end up with fixing the infrastructure related issues, right? So end of the day, your database is a product which is hosted within the infrastructure, and infrastructure is a component which has storage, network, and various other things. Your Linux environment, basically your OS, your kernel, everything is dependent, right? So I wanted to call myself as a good engineer for any of the DB technology. I should know how Linux works. And trust me, like Linux is the future. If anyone is still working on Windows, I would say, guys, take a break, go and start working on Linux based environments, right? So that's the future. And coming to the infrastructure, I was saying that I need to explain you certain things before I actually put on to the final conclusion why Postgres, right? So the basic thing is, for any kind of database, for any kind of database engine, it requires a storage. Okay. So when you say storage, there are different kinds of storage: HDD, hard disk drive, SDD, or flash drives. Okay. So when you say hard disk drives or STD, what is the greatest difference between them? The IO, reads, writes, throughputs, and speed. Correct. So you have to understand what an IO is: input or output operations. What is the frequency, or what is the benchmarking that your disk offers, right? Say if you buy a low quality disk and install something on it, and you complain your database to be slow, it will be slow. uh, one thing everyone needs to understand is, like, not one thing can do all magic. It's a component, and it's a fixed component of everything, which potentially has to put their own efforts. Say if I wanted to have a beautiful and reliable database service for my customer, I have to make sure my infrastructure is 100% resilient, like storage is having a good throughput of IO, and the network is always reliable, there is no packet loss, and always I have a load balancer, right? So to reduce the what you say, the difficulties, or reduce the complexities that we have. Also, I need to have a good Linux distro, which means distro means, say you're installing Ubuntu, someone is using Fedora. All these things are called distributions OS, which are distros. Okay, all these things are open sources. Whatever I say, everything is open source. Just go grab it, go to your Microsoft store, grab it, install, use it as a Windows subsystem for Linux, and you will be able to experience what I'm saying, right? So the reason why I had to stop myself, put up all this explanation, is because Postgres is not only success when it is only a Postgres database. All of these infrastructure things should support Postgres in order to write application data faster, fetch the application data faster, and act what do you say, vibrant, right? Which means being very resilient towards your application data, right? So this is what it all means. So concluding, I would say, many people will have doubt, right? Hey, you're talking about like Postgres or Maria or MySQL, which one should I choose? So the beginning of the course itself, I told you it's all RDBMS, right? Only it has certain pros and cons. Structure wise and the operation wise, there are not going to be much of difference. But say if your application is a web oriented application and it will acquire like so much of connections to your database, you should definitely choose MySQL or Maria, because that is thread based connections. Postgres is system process based connections. It is okay, and it is good to use for applications which have like a high data sets, processing high data sets, not much of a connections, right? So which has difference. When I say like spinning up 100 connections and doing some kind of query, will result me in some kind of benchmarking. And same thing when I spin up like 1 lakh connections and process some small data, that will give me a different benchmarking altogether. End of the day, the problem is not about the connections or the data which is getting entered in. The problem is all about your engine which you wanted to choose, right? So say why I said like the process based and thread based is because now you would have got jargons in your mind. Okay, what is process now, what is thread now? So anyone who learned or like had went through about the kernel designing or like operating system course, or like operating system as one of the academic thing in their career, they will definitely understand process is nothing but it is a process which your kernel will listen to. And and your threads are nothing but basically it is multiple set of supporting processes which will help your process to run faster and end faster, right? So this is why there is a big difference between MySQL, Postgres, and Maria. Okay. Please end session before 8 p.m. Okay. Sorry. When I just get into something, I always focus about what my people audience take end of the day in their mind, right? So I'm always caution about that. And yep. With that, I close this session of Postgres. I hope people you understood something or had better knowledge of what Postgres is now and why should you go for it, or why should you suggest your students to go for it.